Now, what is blockchain? Now, to proceed to talk about the technical aspect of it, let us try to understand the way the global leaders are talking about it. Now, Gartner, you would have heard about Gartner. Now, Gartner says that blockchain has the capacity to generate 3 trillion worth of business a year because of the type of power it will unleash. On the same levels, PwC also says that you will, at least if you are an executive in any corporate firm, at least 84% of such executives would be involved in one or the other form of blockchain implementation in any form going forward. So that is the level of what I would say is that the impact this technology is already having on the business landscape. Now, there are multiple use cases how blockchain can be used to enhance the capacity and bring in trust. But the most important use case which you would have heard about is the digital token technology. This is the technology on which your Bitcoin or this type of coins, which we call it as crypto coins, are based on. The crypto coins which we use, I don't know whether you have used it or not, but you have purchased or you own it or not. But this is something which runs on this technology called blockchain. In fact, advent of blockchain happened because there was an enormous case which came up for having a digital cash equivalent. This happened in 2008, when 2008, I don't know how many of you have heard about the subprime crisis which happened in US, where suddenly banks started collapsing. There was Lehman Brothers, there was other similar type of banks which collapsed overnight because they ran out of cash. Now, when they collapsed, what happened is that people who had invested their money in that also lost their cash because of this collapse. Now, that is the time where people started thinking of it. He started working on it. That can we have a digital cash equivalent? An equivalent where we can transact digitally, but it works more as a cash. Today's NEFTs or whatever you do, UPIs, I think most of you would have done, these are not digital cash. These are electronic payments which you are doing where your bank stores your money and upon your command, upon your instruction, it transfers that money to the another bank. So there is an intermediary in between. You need a bank at your end, and the recipient also needs a bank at his end or her end to transact money. Now that is what we have been working on. That's the traditional way of electronic money which we have been dealing with. But in 2008, people realized that that has its own pitfall because the money is there with the bank, power with the bank, and if the bank collapses, your money goes away. So they decided to work on digital cash concept where banks will never be required any further to store that, and yet you can transact electronically, and that is when they came up with the concept called Bitcoin. It was a paper which was published by an anonymous writer called Satoshi Nakamoto. You would have heard about his name if you have Googled about blockchain. Now this, while he was an author who wrote only about Bitcoin, but people soon realized that the underlying technology of Bitcoin can be put to better use also, apart from using it for digital cash. And that is where the concept of blockchain came out from Bitcoin. So Bitcoin is not equal to blockchain. If tomorrow someone there was, what are the possible uses? They realized that they can put it to for supply chain and logistics. I will talk about why supply chain it can be of good use. Records management, audit, identity management, loyalty programs. Multiple such use cases started coming in. Now I will not talk about what these use cases and the reason why blockchain can play an important role at this stage in this stream. But once we have gone through the understanding of the next few sets of slides where I try to brief or to explain you what this technology, probably you will get to know and understand why these platforms or these solutions can be better leveraged with the use of blockchain. Now, if you look at blockchain, now there are 4 key characteristics which make a blockchain. Now, what are those 4 characteristics? And these are very important characteristics. And please remember that these characteristics are not something new. They existed. They existed in multiple forms. It was only Satoshi Nakamoto or an individual called Satoshi Nakamoto or an institution called Satoshi Nakamoto or a group of people called Satoshi Nakamoto. Nobody knows about it, who is that person. But somebody called Satoshi Nakamoto, what they did is that they brought these 4 principles together to form this solution for us. Now look at the first part of it, distributed ledger. What is distributed ledger? Distributed ledger is nothing but having the replica of the same data in multiple places. So you have, ledger is what, you know what is a ledger. Ledger is some form of a Excel sheet. If you look at an Excel workbook, the Excel sheet which most of you would have seen, it's a ledger. What do you do in the ledger? Ledger has a set of columns, set of rows, and some data stored in it. Now if you take that data, put it into an Excel, and then replicate this Excel across multiple computers. Let's say you have that Excel with you, you have with your friend has with someone, his own friend, and you have replicated across 10, 20 other computers. Now you know that this ledger is in multiple places. So if out of the 10 person who has a copy of this ledger, if one of them decides to play around with the data and changes the data, other 9 can say that this version of data which one has is wrong because all of us, the other 9, has a different version of data and which is similar to each other, each of those 9 people. Now system will realize that majority is right now saying that I have X version of different version of data. So what the system will realize and appreciate that since majority think that this version of data is the right version, it will also agree and it will use that version of the data as the right version. So that by making it distributed ledger and using the principles of democracy where you have majority are saying, giving a certain definition to the data and that definition getting adopted by all of them, you ensure that always data is non-manipulatable. You cannot manipulate it. The data cannot be modified, played around and fudged because the data is copied and kept with multiple entities. So that is one of the important principles of blockchain. The second principle of blockchain is the concept of consensus. Now, when you are talking of consensus, what you mean is that your distributed ledger now is kept with multiple people. Now, if someone tries to fiddle with one part of the data, there is others who are there and who agree that that is a fiddled version. This is the right version. Because majority or with certain algorithm, certain set of group of the data possessors decide that this is the right data. And since that is considered as the right version, what happens is that a consensus is built and the right information is always retained. Any attempt, what happens is that because of this, that any attempt to modify a single part of the data will always be avoided or excluded from the overall ecosystem. So that is the second part of this consensus. So it's most of the democratic principles which we talk about, that what majority thinks is right is actually going to be the right definition. Then comes the concept of cryptography. Now this is also something which existed for ages. When RSA algorithms came into picture, your public-private key encryption came into picture, you know that cryptography was created at that point of time. And in fact, if I may say so, that if I take the liberty to say that cryptography has been in existence for thousands of years. If in a kingdoms, if one king wanted to communicate with another king, and between those two kings there was a hostile territory, the first king would encrypt his message, send it through a messenger to the second the friendly kingdom, all through the hostile kingdom. But if the hostile king caught hold of that messenger, he would not be able to make any meaning out of the content, because that content would have been encrypted. Now the key to decrypt it, key to open it up, would be always there with the second king, who is the friendly king, and he will use it to decrypt it. Now that form of encryption and decryption has been in existence for ages. Now that was digitized in around 1970s by certain authors who brought out models through which they made it more robust and digital. Now, in cryptography, there are multiple forms of cryptography. One of the most popular form of cryptography is asymmetric encryption. In asymmetric encryption, it means one key will be used to encrypt data, and only the corresponding pair key, a pair key exists. The pair key can be used to decrypt it. You can't use any other key to decrypt it. Now, this concept of asymmetric encryption, which was brought in by RSA, which we call it RS algorithms, which we have, which Shamir and I don't recollect the third name, A stands for. So they brought in this algorithm. Now that, once it came into existence, it ensured that content distribution, content movement between multiple parties within a digital environment could be secured and safeguarded using cryptographic principles. So the same principle has been used in blockchain also to secure the contents. Finally, the fourth thing which blockchain has as a principle is smart contract. Now this is something which was not part of the traditional blockchain model which was released for Bitcoin, but subsequently was built in. So even certain traditional blockchain solutions do not have smart contracts, but the newer forms like Ethereum brought in this. Now what smart contracts are nothing but programs which get executed only on certain conditions getting fulfilled. And these programs also reside within blockchain. So what it becomes is that when you recite the content within blockchain, it also has all the strengths of blockchain. And once it has those strengths of blockchain, which I will be talking about, like immutability, for example, that the data in blockchain cannot be ever deleted or edited. So if a data is stored in blockchain which is immutable, even a small program which is stored in blockchain which is immutable, then what we can do is that we can use those programs to execute and validate inputs and the outputs coming out of it. Now, since the smart contracts, if you connect smart contracts with distributed ledger, you would realize that these are small programs which are put into a distributed ledger, which means that this program is also replicated across multiple computers and it runs simultaneously across multiple computers. Now, connected with consensus, you will realize that if an given set of input is given to this program across all the computers, the output also has to be same. And once these outputs are same, then all the machines can connect together to agree that if I have given this input, this is the output. And let's say out of 10, 9 says, yes, my outputs are same as your output. Then you know that this is the right output. And the others are the one rogue element, rogue computer, if it gives some other output, you know that this output is wrong and it has to be excluded. In that way, you build a consensus in a program which runs across distributed environment and comes out with certain common sets of outputs. Then you know that this output is the right output. And this is another important principle of smart contract. So this also was brought in later in the system
to give little more power to people and the users who can now use this type of smart contracts to automatically take decisions. And these decisions nobody can question, because they know that this decision is something which has been derived after executing this program across multiple nodes simultaneously, and multiple nodes have agreed and said that for a given set of input, this is the right set of output. That way, smart contracts came into picture. And these things, 4 principles, actually gave such strength to the system, which we call it as trust, a trustable system, that blockchain became a very important tool for implementing digital use cases where trust was required. Now, when trust was required, what is that? What are those test use cases where trust will play an important role? If I go back to my previous slide, if you see the first one, let's say supply chain, I will just pick up and talk about it. Why trust is required in this? Because there are multiple parties. In a supply chain, there is a producer, there is a supplier, I would say rather, then there is a person who takes that supply and does manufacturing on it. We call it as manufacturer. Then the manufacturer sends the product to a distributor who receives it and builds upon and distributes it to the retailer. Then. So there are, at least to say, in a supply chain, there will be 4 elements, and all the 4 elements have to work together. Now, obviously, these 4 will be different
institutions. If they are different institutions, how do you build trust between them? And that is where blockchain came into picture. Now, I'll give you an example how it helps. Let's look at a farm producer in Kenya who will be exporting produces to, let's say, to UAE, United Arab Emirates. If they will be exporting products to the UAE, does not have its own irrigation or farming facilities, so it depends upon vegetables, eatables, all consumables. It depends upon countries like Kenya and other countries which produces for it. Now, if there is a producer of vegetables in Kenya who supplies products to UAE, a retailer or distributor in UAE, there is a demographic and geographic difference between these 2 institutions. Now, if suppose the person who receives the product in UAE from Kenya, after receiving the product, decides and says that that this product is not of that good quality, that this product was delivered to me late, and that this product I will not pay for this product, then how do you find out who is talking the truth? Is the Kenyan fellow who has produced is talking the truth, that he has supplied it on time and it was of good quality? Or is the UAE distributor who is talking the truth, who said that the date what I received, the products were of bad quality and was received late? Now, if let's say there was one single software which if both UAE and let's say the UAE fellow and the Kenyan fellow was using, let's say there's a single software, and that software was residing with, let's say, the UAE fellow, the UAE distributor, then obviously the Kenyan person can say that UAE distributor has fudged the data which was stored, the timing of the delivery has been fudged, and he can contest that. And likewise, if the software is hosted by the Kenyan producer, the UAE's distributor can also contest that the data is fudged. Now, replace these 2 softwares with a common software which runs on blockchain, which no one owns. It is running on an independent network, distributed ledger sort of a thing. Then you know that neither UAE person can contest the data which is stored inside it, nor does the Kenyan producer can contest it. And that way, between these 2 parties, a trustable system can be created. And that is the precise reason why supply chain, where multiple parties are involved, is a very apt case for blockchain. I'll quickly move to this way blockchain, a little bit of nitty-gritties, or I would say a deeper understanding of, or technical understanding of how blockchain actually runs and operates.
it's important for you, since most of you are coming from a technical background. Apart from having a functional understanding, it's important for you to understand the technical background of blockchain. Now, if you look at the word blockchain, and if you split that blockchain, it is made of two words, block and chain. Now, if you swap these words and inject a word in between called data, then the entire word becomes chain of data blocks. So blockchain split into two as block and chain, and then swapped while injecting another word in the middle called data will result in a sentence called chain of data blocks. Now, actually, blockchain is nothing but a chain of data blocks. What you see in my screen today, at this moment, you have block 1, block 2, and block 3. These are nothing but datas. The data is residing in this. Now, each data is now converted into a block of data. Now, the moment one block is created, that block is signed off and wrapped up and closed. What it means is that once block 1 was created, block and closed, once all the data records were done, then no more block 1 can be edited. Now only a block 2 can be created. And the moment block 2 is created, block 2 is linked with block 1 through a process called hashing. Hashing is again a cryptographic process. So hashing is nothing but creating a unique signature of a data block and storing it with the second block. So what you see is block 2 consisting of hash of block 1 as block 1 with itself in a manner that this gets interlocked. Similarly, block 3 has a hash of block 2. So in this way, a sequence is created. So block 2 has the hash of block 1, block 3 has the hash of block 2. In that way, a sequence gets created and they get interlocked with each other in a sequential order. Now, what it means is that if you try to manipulate any of these blocks in between, let's say I try to change block 2, what will happen is that the hash of block 2, which is stored in block 3, will become corrupt. And when it becomes corrupt, the chain gets broken. The moment the chain gets broken, your blockchain ceases to exist. It is considered as corrupt blockchain, and it should not be thereafter used any further. Now, in this way, what has happened is that we create a chain of data blocks which are interdependent, interconnected in a sequential order, and any one of that block getting manipulated will result in the corresponding all blocks being declared corrupt and ineligible for any further processing. So that way, this concept created a linking systems. Now, just think of it. If you take this entire blockchain, the chain of data blocks, what you saw, and replicate it across all the systems, all the machines which are participating there, the nodes, what will happen is that you can corrupt one node by removing one of the data block or trying to replace it and thus making the other blocks ineligible. But you can't do it for other machines because you may not have access to other machines. Now, other machines, since they all work on a concept of consensus, whatever is the truth which is there, that truth becomes the final truth. And since they have a data block chain which is connected to each other, which is non-corrupt, that becomes the final truth and acceptable truth. So the fact of having a chain of data blocks plus distributed ledger plus consensus ensures that you have a very reliable and trustable system in place. Now, if you come to the screen, what I'm trying to talk about is how does a transaction get into a blockchain in a normal way. See, if let's get back to that example of Kenya and a Kenyan producer and your UAE's distributor. Now, both of them, if they have to work on blockchain to build a trustable system. So what will happen? Blockchain is running across multiple nodes. One node may be running in India, one node may be running in US, one node may be running in Tanzania, one node may be running in Oman, any of this. So there is a multiple nodes which are now participating in a blockchain. So all of them are parties to it. Now let's say the Kenyan distributor has started transaction, it says that this is the produce A, let's say cabbages. I have a ton of cabbages which I'm exporting to UAE. So today at, let's say, 2:30 a.m. in the early morning, I am putting it into the cargo plane for the cargo to move to Dubai for delivering it there. It will record that in the system. It will create that record, send it to the blockchain. Now, how will this transaction get recorded? First, it will become part of a block, what you see. Once it has become a part of a block, that is thereafter transmitted across the entire network. What was the network we spoke of? India, US, Tanzania, Oman, all these countries will get nodes residing in these countries will get a copy of this block which is created. And that block, they will append it to the chain they are maintaining. This chain of data blocks which we saw earlier is nothing but which is built across time by all the systems collaborating and receiving the same set of data and appending it to the same sequence of data which they have kept with themselves. So in a given span of time, all of them will have the same chain with them, and any new data block comes, gets appended to that data block. Then these nodes obviously will validate. There is algorithms, the smart contracts, which will validate that it has come from a rightful source, whether this source is part of the network. All those validation will happen. And once it happens, I will not talk about the proof of work and the algorithms. These are little complex in nature. Maybe we can discuss it some other time. But there is a process of consensus, and one of the most popular is that proof of work concept, through which this consensus is built, verification is done, and the chain is updated by every node in their own copy of their chain is updated by each of these nodes. And once that happens, the transaction is concluded and the information gets recorded. Now, even if UAE's distributor tries to modify this data, or Kenya's producer tries to modify this data, it cannot, because majority of the content is now with Oman, India, UAE, Tanzania, and other places. And if Kenya tries to do anything, automatically the other countries, nodes residing in other countries will say that is not the right version. The version which we have is the right one. And that is 2:30 a.m. And on the same manner, when the UAE's distributor receives it, he also records that same thing in the blockchain by creating a transaction. And subsequently, the transaction gets propagated across all the distributed nodes which are part of that network, and they will maintain the common truth with them. If any one of them tries to modify, the others will say that that is not the right version. I have the right version with me, and this majority says that this is the right version, so everybody will accept that. In that way, you will ensure that this data is non-manipulatable. Now, having understood this technology a bit, what are the outcomes of using this technology? Now, the most important outcome is what I was talking about, is data integrity. When we talk about data integrity, it means that your data can never be manipulated. It is like something which is written once and you can read multiple times, but you cannot edit, delete, or anything like that. So anything which goes into blockchain remains in blockchain forever. Because if you try to edit or delete it, you will have to play around with one of the block of data where it was recorded. And the moment you play around with that block of data, other blocks will become corrupt and will stop functioning. So that is the most important outcome of it. Second outcome is high availability. Now, the fact that there are multiple nodes which are having a copy of the data, even if one or two nodes are down, the other nodes will come up and they will give and tell you that this is the data which I have, and you can connect and fetch that data from them, which means that it provides high amount of availability of information. Third is that you create an audit trail, provenance, what I call it. Why? Because if you see, when I add a transaction, and if I can't delete that transaction, and the fact that that transaction is interrelated through a chain of blocks, I have created a trail of all transactions which has happened, which can tomorrow be utilized to verify the source of a transaction, a source of information, and how it originated and how it culminated. Some of these are extremely important benefits. Now, because of these benefits, the most important point which comes into picture is the most important fact which comes into picture is the fact that it brings a sense of trust into the system. Anybody who uses blockchain gains by trust, because people know that the data, content, everything will always be available and cannot be modified at any point of time. So you tend to start getting trust on the system, and it builds trust. So wherever there are multiple parties and there is a lack of trust and understanding, this technology plays an important role to build that and bring that back. And that is the reason I said that this is an emerging technology. This is a different, it's not a part of traditional technology, but this technology goes to complement the traditional technologies by bringing the fact of trust into it rather than replacing those technologies. Now I'll talk about some of the use cases which we have worked on, and this is one which I feel is one particular use case which stands out. Now, this is a process of blockchain which we implemented in Karnataka in the property registration system. What we did in the property registration system was that one of the biggest challenge in property registration system was that there was no verification of owner's identity. If I am coming to sell a property, there was no process to validate whether I am an authentic owner of this property and that I am entitled to sell this property. That was never verified. Only way to check this was the information which this person is bringing. So if I go to a registrar's office and I say I own this property, the only way the registrar can validate it is by looking at the documents which I possess with me. One of the document is the previous original deed document which I have. I can take that original deed document, I can go and say, see, this is the original deed document of the previous transaction through which I was given the ownership. So now I am selling it. Now that paper-based document obviously can be fudged. It can be fabricated. How hard it is to create a document which looks exactly like any of the deed documents and present it for transaction purposes. It is not difficult. It's very easy to do that, and people did it also. Now, what blockchain we did is that we created a concept where we said that every transaction which we do will create a data transaction. That data transaction will be recorded in the blockchain against that property. And that information will be linked with this individual through a wallet. A wallet which we said will be hosted on a card, a smart card. So if you see, I'll show you one picture here. If you can see this picture, and this is the person, he's one of the property owner who is holding in his hand a wallet which we call it Bitcoin has a wallet. We have multiple things, but this wallet has been formalized into a factor which you see in the hand of this farmer, which is a smart card. And the smart card has a chip. This chip has his contents, his unique identity, which is mapped with his document, his transaction details in the blockchain. Now, what happens is that whenever you try to do a transaction on top of that property, first thing what blockchain does is that it looks for the previous transaction. The moment it finds the previous transaction, it tries to verify whether the current person is rightful owner of the transaction and can he conduct a new transaction. How will he know that? Through this wallet. The person has to present the wallet. The wallet is used to map and match the contents with in the blockchain. If the content matching happens, you get to unlock the transaction and proceed with a new set of transaction on top of it. In this way, we were able to do two things. One, we prevented any fabricated attempts to sell someone else's property. Second is that we also created a traceable link. Now with this wallet, since transactions are linked with the wallet, now next time when you want to understand how many transactions have been done on a certain property, this wallet details can be used to link them together and create a very sequential set of transactions which has happened on the property. So it's a very complex algorithms which we had to develop because property registration consists of multiple types of use cases, and we implemented most of them. So it was a very successful project which was executed in Karnataka. The second project which we did was on e-attestation. Now, you have mark sheets. Now, if you go for an admission into for higher education or to some other institution, your college, wherever you're applying for your admission, will ask for your previous mark sheets, TCs, and other type of documents. Now, how do you give those documents to them? The only way of doing it is that you take a photocopy of the originals which you have, go to some gazetted officers, get it attested, and then go and submit it to that new college, and they read that, verify that, and they accept that and proceed with it. But in that also, obviously, there is always a chance of fabrication. How do you know who has signed it? The seals can be fabricated and fudged. How do you know there are genuine things are happening? For this also, what we did is that we created a blockchain-based solution. Now, what happened is that you go to your college principal or the source college principal or will upload your mark sheet into the system, sign it digitally through his e-sign, through his Aadhaar number, and store it in the blockchain. And you will get a unique reference number. When you go to the new college or new place for higher education, you give the reference number. Through that reference number, the new college will be able to verify your mark sheet and will be able to validate with that it has been genuinely created and entered by the source or the college from where you are moving out and moving into this new college. So through that blockchain, they would be able to verify that. This was used for disbursement of scholarships. They're still being used for disbursement of scholarships, where before delivery of scholarships, it's important to know that whether you are a student, whether you have studied, whether you have achieved the relevant marks, everything is required to be understood and known. So in this case, all this data, the principals of the schools and colleges are uploading these relevant data into the blockchain attestation software, and the scholarship authorities use that information to validate, understand that what is the whether this person has the requisite eligibility based upon which the scholarship can be disbursed. So this is another use case which we have. One interesting use case is on crowdfunding. Now, this is nothing but the fact that you are receiving money from multiple sources. Now, if you take that money and record the details in a normal database, there's always a chance that somebody from the backend can go to the database and change the content. So if you have received 1,000 rupees in grant, you can go and change it to 100 rupees and show to the auditors and other person that I received only 100 rupees, not 1,000 rupees. Now, what we did here is that we placed the entire content into blockchain, and any crowdfunded amount, any amount which was given was recorded into this so that it cannot be manipulated, and tax authorities or the higher authorities know that this is the total amount of collection which was done. This was used for some projects, social projects in West Bengal. Similarly, we have another use case on title mutation, which is quite similar to the use case I spoke about Karnataka. Now, these are some of the use cases which I thought I'll share with you. There are multiple use cases in public domain, and you have all the opportunities to go through those use cases and understand the benefits of those use cases and why blockchain is being used. So I will pause and stop here at this stage. Before I conclude, I'll just talk about the organization which I represent. I am from Center for Smart Governance. It's a government of Karnataka entity, and we are into building software solutions for government departments. We take pride in the fact that we, unlike any other corporate organizations where we work to strengthen the top lines and bottom lines of corporate bodies, We actually do not do that. What we do is that we work to make impact on the lives of individuals. We change their lives. We bring smile to their faces. And this picture, which I showed you some time back, actually represents that, where we have brought technology to the grassroots in the hands of needies, through which we are ensuring that their rightful ownership is never fabricated or manipulated. So that is about this organization. That's about my presentation. I thank you for patiently listening to this, to my presentation. I hope I have been able to add value to your knowledge, existing knowledge, and now I'm open for any questions which you may have for me. The voice is not clear. It's a little muffled.
Is it clear now, sir?
Yeah, this is better.
Sir, really thank you for actually coming to this session, sir. We are thankful for this. If it's not audible enough, people are actually clapping here and we're really happy, but the distance is making it difficult for you to hear. Thank you. So there were a few questions that actually came up, sir, but before that, really thank you for showing the practical implementations of these applications of blockchain, which we rarely get to see, because most of the times we are just mentioned about technology and not how it can be implemented. So thank you for that, sir. And the first question was actually posted was about ChatGPT and its influence on blockchain. So there's a huge question. I'll try to condense it down. So they want to know about how ChatGPT is able to generate coherent and contextually relevant responses. So what kind of techniques can be used to incorporate blockchain into this and make it in a way that it's Web3 compatible?
Okay. Now, see, I'm not an expert in ChatGPT, but what I know from public sources, I can talk about it, is that ChatGPT uses artificial intelligence. It has nothing to do with blockchain as of now. It uses artificial intelligence. Now, what artificial intelligence means in this case is that it also behaves something similar to you. When you go to Google, when you want to get some information, what you do is that you go to and visit Google. When you go and visit Google, what happens is that you are, based upon your understanding of your need, the question, you keep on changing your parameters, queries, and you build upon that information. You get certain insights, then you again change your question, again search in Google, get some more insights, and you build upon a full response to that. The exact same behavior is modeled by ChatGPT. It receives it based upon your question which you ask. It creates multiple subsets of those questions, keeps on pouring through the enormous database of internet, finds responses, collects them together and presents it to you. There's only two options. You may like that as sufficiently enough information, or you may not like it. What it does is that it records that behavior. If you like that answer, it knows that it has done a right thing the way it has searched, and it builds upon that information. And again, next time it replicates the same model to search it. So it builds upon those models using user experience and its own information and inputs. That is artificial intelligence. Now, as far as blockchain is concerned, there can be multiple use cases of convergence between this and that. Means this is something which I would leave it for all of you to imagine. As of now, there are no such use cases, but I'm sure that the world is quite big enough for multiple brains to come together and come out with certain models. And maybe some of you can be those intellects who will develop such models. But as of now, we don't have any such use cases.
I think that will be an answer for people of this question. So the next question was regarding internships and future opportunities in government sectors on blockchain. Working on blockchain, they want to know what are the future opportunities right now in government sector to take up.
So government is excited. I think one of the most important test bed When I say test bed, is a place where you can test your theories, your transactions, your tools, your technologies. One of the most important test bed is government. The reason why I'm saying that government is a very important test bed, because you cannot find a more prolific, extensive and large set of user base which you can see in government in any other place. You go to some sort of a small, let's say, insurance firm, AIG. AIG's user base is its customers. You go to Tata's will be customers. But when it comes to government, the entire country, entire landscape, entire geographical entity will be your use case. So it is one of the best place to put test any of these technologies, and because of which I have interacted with almost around 10 to 15 state governments. I know that they're very excited. They know this technology has a lot of benefits. One of the project which I did not speak about today is your procurement through blockchain. Now, we need a huge amount of authentic data of all suppliers, whether the supplier is an authentic supplier, whether he had supplied earlier to any agency or any government, whether that supply was correct or not. That type of databases now government is building on blockchain, because what happens is that in that you allow multiple state governments and national governments to collaborate with each other, maintain a common system, and also create a non-repudiable source of information. So that's one of the use cases. Land records, I have told, that's another use case. Fertilizer and other subsidies which we give, so many subsidies which we give. There's so much of opportunity of improvements in that. There's so much of siphoning which is happening. So plugging those loopholes. So government has a lot of opportunities for technologies like blockchain. It is important that you build your skills on that, and the more the skills, the more the availability of knowledge base, the more adoption will happen. This is just a cyclic process, I would say.
There's actually one question from the audience here as well. So please come forward as
Good evening, sir.
Good evening.
I'm Amur from fourth year in computer science, and I have been interested in blockchain and related technologies for like the past year. I was also impressed by how you implemented the blockchain technology in the government sector. But my question and my doubt was, as I was reading and learning about blockchain, I found out that the strength of a chain is determined by the number of independent nodes that are running. Like, as in, if Bitcoin was being run by 10,000 Chinese, let's say, servers and 5 Indian servers, the strength of the chain is obviously skewed towards, let's say, Chinese users. And if they collaborate, and they can obviously manipulate the chain as they see fit. So, how is it that the government is ensuring that these kind of manipulations will not happen? Or for that matter, any central organization, how can it ensure that technology is implemented in that, like the blockchain technology implemented there, is not immutable? Like, there cannot be a possibility of an attack from inside the chain to change the blockchain Bitcoin.
Very good question. And honestly, you are not the first one. In fact, Donald Trump was also a person who knew this, and that's the reason he is one of the biggest opposer of Bitcoin, because this is a fact. You are right. 70% of miners in Bitcoin are Chinese. Now, obviously, the reason is that in China, power is cheap. Unlike in US, per unit of power is very costly, and for mining Bitcoins, you need a lot of power. So China has invested on it, and they have developed it. So at any point of time, it can be manipulated by Chinese authorities. Although it may not be so easy, because the moment you start manipulating, you are getting expunged from the network. But having said that, there's always a possibility. I will not say there's not possibility. That's the reason I would say, and again, that things like Bitcoin are not a good place to invest your money. These are speculative in nature. And that is the reason Government of India came with its own e-rupee. Because if tomorrow Bitcoins became a global currency, it will be in the hands of certain individuals who can mine that currency, and they can always determine the cost, the value of Bitcoin. And when the value and cost of Bitcoin can be determined, then obviously the country, then its own reserve bank systems, federal systems will not have any control on it. That's why you are right. I would say you are right, and that's one of the major concerns for many national and international authorities, because of which Bitcoin has not been able to get any type of adaptability or acceptance, except for very few reneged countries, Venezuela or some other countries have done it. But major economies have avoided using Bitcoin. But having said that, what I am trying to say, blockchain as a system, let me come back to one of the core point of it. Again, the way you implement is more important. Now, if you create a blockchain system which does not skew towards any particular power source, it is independent, it runs without any dependency on anything, you will be able to leverage a lot of benefits from it.
Yes, I think I have a follow-up question.
Sir, as you, sir, in your answer, you mentioned that that is why Indian government is also coming up with its e-rupee. Sir, wouldn't it also, like, just like the Chinese like weighing over Bitcoin using sheer power, wouldn't it also mean that using the governance that RBI has over e-rupee, it can also skew the chain in its favor, or however it likes?
Absolutely, you are right. It is possible, but that is the reason it is important that proper thought is given to how you implement this system. Now, see, for example, when we were implementing blockchain in Karnataka, now if you look at the administrative setup starts with a department, and department reports to its main mother department. We call it as admin department, and that department reports to the government, state government, and the state government now obviously reports to, or I would say connects with the national government, if not reports. Now, if you create a blockchain where all the nodes are within a certain department, then the department head can always manipulate it. Now, in how to avoid it, then make it at the multi-departmental. So one department head will not be able to manipulate, but then the state government head and the state government can manipulate it. Then how to avoid that? Make it a system which runs across multiple state governments. So one government may manipulate, the other governments will not be able to. So you will strengthen it. If all the state governments decides to manipulate, then it's a different question. So coming back to this and the previous question, there are multiple now models of blockchain which is in use. What we are talking of is the primitive and the most old and the most prominent version which we see is Bitcoin version, which depends upon this type of majoritism sort of a system. But there are new algorithms which has come, which now allow you to function without giving extra power in the hands of any individual. But again, that is how you model it. The way I said departmental, government and all those type of things, how do you model it is what is very important to generate trust in the system.
Yes, thank you for that, sir. Like, it really, there is a point where everything fails when majority of the people shift towards any opinion. And this was the same case for multiple times in history, and hopefully it doesn't repeat again in this scenario. Do you have any follow-up question to that as well? Sure. So now we'll just be taking any audience question if there are any, or else we'll be done for the day, sir. Just a moment.
Sure.
Are there any questions to be asked? Are there any questions? Thank you, sir. These were the only questions that were actually posted online, and also by this we can also see that many people are not highly aware of blockchain, so I think questions may have been quite difficult to come. But yeah, I think within the next few years, everyone will get accustomed to it, and we'll end up, the next wave of internet, I guess. So thank you for this, sir, and thank you for sparing your time with us.